Here we are with section 1.3 in your pre-calc 12 workbook. Deals with composite functions, or what we call composition of functions. Excuse me. What this basically deals with is putting functions within functions. So we looked last section at adding them, subtracting them, multiplying, dividing them, and we saw how it changes the function a little bit. What we're looking at now is how we have functions inside functions. Now, as an example, what we can do here is look at something like this. We have two different things going on here. If you didn't have the radical sign here, you'd tell me that was a linear function, right? But you do have the radical sign. So what we have is a radical function on the outside and a linear function on the inside. Okay, so it's a combination of functions together. And for the notation, what it means is that, well, let's look first. We have a function in a function. Okay, there's an outside and an inside, and it looks like this. F composite G of X. This is the notation that we have. Okay, fog, I guess, if you want. Depending on what your functions are. What this means is that the outside function is f and the inside function is g. So you have f of g of x. Well, what the hell does that mean? Okay, well, let's take a look. Hopefully you know. Well, let's have a look at this. If I gave you, this is function notation here. If I said x was 3, what you would do is put a 3 in for x, right? And you could actually solve this. F of 3 would be the square root of 7. There you go. That's it. Okay? We've got to keep that in mind when we're doing something like this. If I have, for example, f of x being 2x squared, and then I have g of x being 3x plus 1. Okay? If I give you f composite g of x, that's the same as saying f of g of x. So now, instead of this is f of g of x. So in the f function, we put the g of x. So it's going to look to, well, what's your x? Your g of x is 3x plus 1, all squared. This is, you've put this function into this one here. This x here ends up being this whole thing here, right? This 3x plus 1 is my x. It goes inside, so it becomes 2 bracket 3x plus 1, all squared. We can FOIL it out, multiply it out if we want, but we're just leaving it like this for now. What happens if you turn it around? What about if I said g composite f of x? Right? Well, that would be the same. The outside function now would be g, and the inside function would be the f of x. So that's going to look like this. In the g function, you have this. So it's going to be 3. Well, what's your x? Your x now is the f function, 2x squared plus 1. Now you have the linear function on the outside and the quadratic function on the inside. These are significantly different answers, because we've completely reversed this. We put the g function in the f function here. Here we put the f function in the g function. We can look at another couple examples if you like. Let's have a look at, let's say, f of x is equal to 1 minus x squared, and g of x is equal to 2x plus 3. Well, if we look at f composite g of x, right? That's the same as saying f of g of x. Now, you're putting g of x into x of the f function. So you're putting g of x into x of the f function. So it's going to be 1 minus x. Well, x is g of x. So it's 2x plus 3. 2x plus 3 all squared. And then, depending on what you're being asked, you can multiply it out. If we're looking at g composite f of x, that means that you're putting the f function into the g function. So this is the g function 2x. What's x? Or what's f of x? Sorry, f of x is 1 minus x squared plus 3. There you go. Again, completely different, but doable nonetheless. Let's quickly have a look at this. If I got rid of that, let me just do this here. Now we can also take it a little bit further and say this. How about f of g of 2? Okay, well you could find f of 2 and you could find g of 2. F of 2 would be 1 minus 4, which is negative 3. G of 2 would be 4 plus 3, which is 7. Okay. Wait a second, I don't know if that's going to help me, but let's check this out. Look, f, yeah, it will actually, of g of 2. Well, what's g of 2? G of 2 is 7. So that means that this is going to be f of 7. So I don't need f of 2. And f of 7 would be 1 minus 49, which is negative 48. Okay? If I want to do g of f, or sorry, g composite f of, let's say, negative 1. Well, that's going to be the same as saying g of f of negative 1. Well, what's f of negative 1? Let's have a look. F of negative 1. Negative 1 squared is 1. 1 minus 1 is 0. So that's actually 0. So this is going to be g of 0. And what's g of 0? G of 0 here would be 2 times 0 is 0, plus 3 is 3. Okay? This is the composition of functions, putting one function into another. What we also have to deal with, though, is a decomposition of functions. Or let's look at decomposing a function. We're actually going to break it down, okay? Now, you might have a situation where you have, let's say, let's call it h of x is equal to the square root of x minus 2. Well, what's the outside function? The outside is the square root of x, right? And we can call that, say, f of x. Let's call it f of x. And then the inside, okay, the inside looks like a linear function. It's x minus 2. Let's call that g of x. Hopefully you can look at this thing and see that the outside function, right, the outside function is the square root, so that's going to be the first. So h of x is the same as saying f composition of g of x, which is f of g of x. Okay, and you can often check out your work as well if this is what you called it, right? F composition g of x. So that's going to be f of g of x is x minus 2, right? And if x minus 2 is the x value, it's going to end up being the square root of x minus 2. Boom, there you go. It becomes the square root of x minus 2. So it's kind of going backwards. These aren't always unique. Okay, you might have a couple different ways that you can do these decompositions. There might be a couple different answers. They will all be acceptable as long as they make sense. So composition of functions, folks, and then decomposing a function. Any questions? We'll deal with it in class. Hope that helped.